All right, ladies and gentlemen, welcome to the drive-through, sponsored by the deli. Hungry? Stop by the deli. Make yourself a nice plain turkey and bologna sandwich on wheat with Swiss cheese and spicy mustard. That's what I had today. It was delicious. Big shout out to Mr. Pletz for bringing in the cashews as well. All right, was one of the harder questions on the review packet here. Find the component of U, which is 6, 7, orthogonal to vector V. So first let's just widmapoi. U is 6, 7. So there's U. And V is 1, 4. Okay, so if you remember, what the projections are is that it's very easy to kind of envision the projection of U onto V. We've always done that to be like a flashlight. So if we shined a flashlight on to U, okay, its shadow that fell onto V is going to be something like that. Okay, now I'm going to take those off for now, and I'm just going to get to doing the problem. We're going to need to use the projection vector to find the component that's orthogonal. So, if you remember, and hopefully this is one of the equations that you guys will use on your note card, the projection of U onto V, well, it involves the dot product, right? So it's U dot V, and then we've got to put it over the magnitude of V, and you got to go back and watch the old videos if you want to know why, okay? But then you got to multiply this whole thing by vector V. Remember, what's inside this is just going to be a scalar. Yes, it is. Yes, it is. Well done, Josh. Okay, it's the magnitude of V squared. Again, that's why we want those on our card. I don't expect that you guys are going to memorize those. Hopefully they make sense. All right, so U dot V is going to be 6 plus 28, so that's 34. The magnitude of V is radical 17, so radical 17 squared is 17, so that's nice. That's just a 2. So this right here is the magnitude of vector U that is traveling in the direction of the pink vector. So now I just rewrite the pink vector, 1, 4. And then we know that the projection of U onto V is, this is a 2, right? That's a 2. So it's 2, 8. So check that out. Our shadow of our flashlight is going to be this. Okay? So the amount of our blue vector traveling in the direction of the pink vector is the black vector. It's 2, 8. Does everybody get that? Okay, so now, if you don't understand the geometric interpretation of vectors, it's going to be very hard for you to understand this next step. This next step is the solution to the problem. We are trying to find the component of U that is orthogonal. Well, let's use a different color. That, right? Well, notice that's that. Okay? So, another way to find this green vector would be to take U, all right, and then subtract the projection of U onto V. We called this green vector W in our notes, okay? So one of your rules is that W is U minus the projection of U onto V. Now I hope you understand why that is, because of this little rectangle that it forms. Okay? So our answer for W is simply going to be 6, 7 minus 2, 8, right? And that is a 4, -1. And check that out. I'll erase this. 4, -1. And there it is. It's exactly orthogonal to the pink vector. And that's how you get it. So that's a good one to ask. You can almost guarantee that one of those will be on there, and that'll be one of the harder questions on the test. So this should be a very doable test.